Hey everybody, we are from Group C2 and we're going to present about whiskey production based on our last experiment, which is batch distillation process. So let's introduce to our group member. This is me, Danish Kumar, T Hok Chu, Teo Kawai, Sam Yin Yan, and Soro Patrick. So let's move on to the introduction. So basically, the basic use of alcohol is actually, for example, perfume because it vaporizes quickly, chemical agent to dissolve many solvent, for example, nail polish, and lastly, in medical uses, for example, to clean the wound.
Next, moving on to the history. Early archaeologists suggested that or indicated that Babylon and Mesopotamia is the first or early stage where whiskey produced, but it was not as commercialized as right now. So, moving on, why alcohol begins as a beverage. So initially alcohol is basically used as perfume and aromas, but in Europe, Christian monasteries demand the producers of alcohol to actually make beverage out of it with a variety of flavors for a part of their ritual. So this caused Ireland and Scotland to produce or to initiate the first whiskey production. So what makes whiskey unique? Due to the low grapes access to grapes, grain were used as a substitute as a raw material. Before this, alcohol was made from fermented grapes, berries, and other fruits. So, when beer is produced, then it is distilled to produce whiskey, which is correlated to what we have done in the first experiment is distillation, where during distillation, a substance which is more concentrated will be produced. This means that whiskey is much more concentrated than beer, and indirectly means that whiskey has more alcohol content. So even though the process of actually producing whiskey is really difficult and challenging, but it's worthful for its taste and of course its capital profit. Right. The objective of this experiment is to determine the height equivalent theoretical plates at total reflux, in other words the efficiency at total reflux, to determine the effect of liquid and vapor loading on the efficiency at total reflux. Thirdly, to operate a batch distillation unit at constant reflux. The fourth one is to examine the change in the top and bottom composition and the efficiency over time in a batch distillation. Last but not least, to carry out mass balance calculation on the distillation unit. So moving on to the next section is the customer requirement. We cannot summarize several groups of customer for whiskey usage, but we represent in a whole term of a demographic view on whiskey usage. As you can see, European Union, dominates the chart by having 34%, which is countries such as France, Spain, and Germany. And Asian market tops by Singapore. Now let's look on to the customer choice of whiskey. Basically, in this section, we actually representing the top seller of whiskey brands, which we shortlisted to 3 brands that the customer demands are high. So third in the list is called Crown Royal, which it stated from statistics is that this company has a decline in 4% of production in 2014. Well, even though it is 75 years in the business, but it was not unique enough to boom its sale. So next, moving on to the second in the list, Jim Beam, where indicate that 7% in 2014 increase of production with 7.4 million cases. The brand has popularity in Japan as one of the parent company has invested there. And plus with its cinnamon flavored whiskey grabs the attention of customer. And of course, it also takes place in fast Indian market too. And of course, first in the list as a world famous whiskey brand called Jack Daniels topped the list as the most demanded brand in around the world. So it has impacted a huge part in the whole American whiskey over the past years and allowed its parent company, Brown-Forman, to constantly account for firm growth at a time when most multinational drink companies has experienced major breakdown. Jack Daniel also has introduced two new flavors called Tennessee Honey and Tennessee Fire Expression. With these two new flavor, it has hold a record of 1.2 cases in its total annual sales, making the strong performing flavored whiskey on the planet. So next we are moving on to the market demand of whiskey industry as general. As you can see from the graph above, the whiskey import has a gradual increase over the years of 2010 to 2014, and this source is from the Distilled Spirits Council of the United States. Whiskey has gained its popularity, but the demand of imported continues to increase. Conversely, the import growth rate has slackened, which means that the rate of increasing decrease, but still demand is there. The whiskey in the United States raised by 2.6% to 1.7 billion in 2014, comparing to previous years, which is 16.5% in 2013, 12.3% in 2012. So, according to the Whiskey Association, the United States is a top importer of Scotch whiskey. Still, Scotch whiskey imports in the United States dropped in 2014, and existing records meets the consumer demand instead of newly obtained stock.
So the barley and the other grains will be put into the grinding mill to grind it into a powder form. After that, it will be sent into the donut tub and cooked with water. The purpose of sending the powder form of grains into a donut tub is to allow the natural enzymes in the grains to start breaking down the complex starches into simple sugar. Once the grains are turned into dextrose, they are ready to be fermented. The dextrose, which was prepared in a mash tub, is transferred to a fermenter for processing. In the fermenter, yeast is added. Certain yeast, as they consume sugar, they will give off alcohol and also carbon dioxide. In order to raise the alcohol content above 14% to 16%, it must be concentrated through distillation process. Distillation or rectification, as it is sometimes called, separates the alcohol from the other liquids and solids that make up the converted mash. This converted mash is called beer. The beer is heated to the point where the alcohol boils. Fortunately, alcohol boils at 172.9 degrees Fahrenheit, while water, the other main liquid in the beer, boils at a higher temperature of 212 degrees Fahrenheit. As the alcohol vapors are given off during the boiling, they are collected and passed through a cooler. The cooler condenses the hot vapors back into a liquid, minus most of the water. From here, the alcohol is ready to be used. To smoothen out the taste to where you have very drinkable alcohol, the alcohol is placed in a wooden barrels. The barrels are stored for numbers of years. After aging the alcohol, it is ready to be bottled and consumed. That's all for my part. I would like to invite T Hok Chiu to explain the equipment involved in this process. Thank you.
Good evening everyone, my name is Teo Chu. I'm going to explain about the equipment and unit description. As you guys seen earlier, just now the process for regular explained by the Saming Yen. Well, I'm going to explain about the important equipment in the process industry. Well, the first one is mash tub. What's the function of the mash tub? Function of the mash tub is converting starch into sugar. Besides that, we also got the donut tub. Donut tub, you will cook a mixture of the water, hops and melted barley and yeast. Then yeast tub, as you guys can see, you store the yeast for the next process. And I think fermenter. I think most of us are familiar with fermenter. The function of fermenter is converting sugar to alcohol. But last and not least, the most important part in the process industry, which is batch pack distillation column. In batch pack distillation column, we got few important equipments. Well, the first one is valve positions. Got many valve position in batch pack distillation. While the function of valve position is to control the flow of liquid and vapor in the system. Then the second one is heater power. Well, the function of heater power is can vary the flow rate of the vapor and liquid inside the distillation columns through adjusting the heater output power between 0 and 100%. And next is reflux divider. The controller had three positions, which are total reflux, which is the position is 0, total distillate offtake, which the position is hen, and the position control reflux, which is the position shows auto timer. And the next one, inside the distillation column, we got the packings. Well, what's the function of the packings? The function of the packings is hold up the liquid to provide better contact between vapor and liquid for better separation achievements. Another one is reboiler. Reboiler provide proper vaporization for the distillation process. And the next one is the condenser. Condenser, it will cool down and the condensed vapor that living at the top of the column, while the reflux drum hold the condensed vapor that living from the top of the column. Last and not least, pot still doubler. What's the function of pot still doubler? The pot still doubler function is adjust proof and 125 degree maximum, which is used to denote the alcohol content. After we adjust the proof of the alcohol level, we will put the product inside the holding tank, which is holding the final product of the process, and we'll send the final product of process into the barrel, which we keep the whiskey inside the barrel for several years and let it aging. Okay, next I would like to discuss about the result and data for our experiment, which is done in UTP. Well, the first experiment we done is batch pack distillation at total reflux. Well, the objective of this experiment is determination of the height equivalent theoretical plates at total reflux. The second objective is determination of the effect of liquid and vapor loading on the HETP at total reflux. Well, the experiment 2 is batch pack distillation and at constant reflux. The objective for this experiment 2 is operate a batch distillation unit at constant reflux. The second one is analysis the change in top and bottom composition and the height equivalent theoretical plates HETP over time in a batch distillation. And the third objective is carry out mass balance calculations on the distillation unit. Well, next I would like to explain the tabulation of result of our experiment. Before we did our experiment 1 and 2, we did another part of experiment, which is a preparation of refractive index versus composition plot. Well, while we doing this experiment, we take the different mixture of ethanol and water, which is different percentage of volume, and we measure out the refractive index of each solution. Well, we can see from the graph, which is refractive index versus the mole fraction of ethanol. And from what we conclude from the graph is, higher the mole fraction of ethanol shows that the higher of refractive index, which shows that refractive index is directly proportional to the mole fraction of ethanol. Next, I would like to explain the experiment 1 that we did in our experiment, which is batch distillation at total reflux. From the graph 2, we can see that the vapor mole fraction versus the liquid mole fraction. From this graph, we can determine the number of theoretical stages at the heating power, which is 100%. And from the graph, we can see that only one theoretical stages that we can conclude out from this graph. Well, the next graph is HETP versus the heating power. From the graph, we can see that although the heating power is changing, the HETP is remain constant through all of the process. Other than that, I would like to explain about the experiment 2, which is batch distillation at constant reflux. So from the graph 4, we can see that 1 over y minus x versus mole fraction of ethanol in the reboiler SA. From the graph, we can see that 1 over y minus x is directly proportional to the mole fraction of ethanol in the reboiler, which is SB. And the next graph, which is the final graph, graph 5, is the mole fraction of ethanol in the reboiler SB versus time. As we can see, the mole fraction of ethanol in the reboiler SB decrease as the time increase. So this is the conclusion part for our experiment. Thank you.
Good evening. I'm going to talk about safety considerations. In the production of whiskey, there's production of ethanol, which is highly flammable. So in that case, there's generation of dust, fuel, and then vapor, which is highly explosive. So in that, we have safety considerations to take into place while working in the whiskey plant. In the workplace, the safety of the workers and the environment around is important. Hence, safety precaution and other considerations need to be put in place. This includes the following. 1. Warning signs. Warning signs should be placed in slippery areas, non-potable water features, low head clearance areas, open surface manholes, hazardous chemicals, storage areas, flammable fuel storage areas. This ensures that workers are not exposed to high risk. 2. Assessment of equipment and electrical equipment should be ensured. This makes sure that workers are not put in danger. The third point is hazardous area classification. In case of flammable sources, assessment of ignition sources and their elimination in areas are needed to be done. Fourth point is the plant personnel should wear protective clothing and equipment such as self-contained breathing apparatus, chemical workers goggles, dust masks to protect lungs in chemical areas, rubber gloves and boots, safety harness line. Chemical handling and safety. In the production of whiskey, there are other chemicals that need to be handled with care. The chemicals involved include the following. One is ethanol. Ethanol is highly flammable liquid with a relatively low flash point. This can cause explosion. Therefore, should be properly stored to avoid the risk of explosion. Two is carboxylic acid. Carboxylic acid is risky in a way that when workers are doing maintenance, sampling, analysis, there is a risk of exposure. So in that case, care must be taken. They have to be stored properly to avoid the risk of workers inhaling them. The third one is esters. Esters are highly flammable, especially low molecular weight esters like methyl formate. They have low flash point, wide flammability, so workers need to handle them with care. They must be taken care of in a proper storage place.
Good evening, everyone. Hi, my name is Kawai. So today I'll be talking about economic analysis. So the whiskey production needs a very detailed understanding and its operation to understand how much it costs from scratch. Due to its different circumstances, it is not easy to estimate the cost of production of whiskey. So there will be the total production, the cost of whiskey can be divided into four main parts, which is materials, services, and also capital. Last but not least, the labor. As you can see from the chart of domestic expenditure, 35 million have been spent on materials, whereas 64 million have been spent on services, whereas the most spent, which is on the capital, which is 90 million, and the rest will be on the 45 million on the labor. So total overall have been spent is around 237 million. In the capital, 90 million have been spent. Financing costs and warehousing costs are one of them. Financing is the funds to finance the inventory from the time of production until a sales takes place. In the services, the transportation cost is included as well. Whereas the whiskey will be transported by train, food and other drinks can be carried as well with the Scotch whiskey. The usage of train can reduce the emission of carbon. Okay, in the material part, woods, bottling, and also packaging materials are included in the materials. Wood is needed to build the cask in order to store the whiskey. Bottling is the packaging of the case of whiskey, whereas the packaging materials is the material to wrap the bottle. Last but not least is the labor. Labor is important as well, as the workers will help operating the company, which indirectly will help the company to make profits. Thank you.
To draw a conclusion, generally the objective of this experiment has been achieved. At total reflux, as the heater power increases, the number of theoretical plates also increases. At constant reflux, as time increases, the mole fraction of ethanol in both distillate and bottoms increases. The mole fraction in the evaporate increases with respect to time. However, HETP increases as time goes by. This scenario can be applied in the distillation of whiskey, in a big plan with the whiskey at the top as distillate and water as bottoms. This marks the end of our presentation. Thanks.